Question 8. Much more fun. 7 marks. Coordinate geometry. Much more mark T. So, in this question, we must use detailed reasoning. The centre of a circle, C, is at the point -1, 3. And C passes through the point 1, -1. The straight line L passes through the points 1, 9 and 4, 3. We want to show that L is tangent to C. So, before we do any maths, let's think about what that means. So, if L is tangent to C, then solving L and C simultaneously will only give one solution, because a tangent only hits a circle at one point. So, game plan, we need to find the equation of the circle, the equation of the line, solve them simultaneously. Okay, let's do the circle first. So, a circle, centre AB, radius R, has equation x minus a squared and y minus b squared is equal to r squared. Now, we can get the values of a and b here, because we know the centre of the circle is -1, 3. So, centre is -1, 3. That means then C is x plus 1 squared and y minus 3 squared, and that is equal to r squared. Now, how do we find the radius? Well, we also know that this circle passes through a particular point, and that point is 1 minus 1. So we know that x equals 1, y equals -1 satisfies C. So, we substitute those values in. So we're going to get 1 add 1 squared, which is 2 squared, which is 4. Add -1 minus 3 is -4, but square that and we get 16. So we get 4 add 16 is r squared. Therefore, r squared is 20. And C has equation x add 1 squared add y minus 3 squared is equal to 20. Cool. Okay, now let's do the line. So we know that L passes through 1, 9 and 4, 3. Okay, so 1, 9 and 4, 3. So, first of all, to find the equation of a line, we need the gradient. So, gradient is difference in y over difference in x. So, whichever way we do it, we're going to get a negative. So I'm going to do 3 minus 9 over 4 minus 1, which is minus 6 over 3, which is minus 2. So, using MX and C, we now know that L is y is equal to minus 2x add c. To find c, we substitute in a pair of coordinates. So let's use 4 and 3. So x is equal to 4, y is equal to 3, tells us 3 is equal to minus 8, add c. So c is 11. So L has equation y is minus 2x add 11. Okay, so now we have our two equations. So we now know then that y is minus 2x add 11 and x add 1 squared add y minus 3 squared is 20. Okay, so we're now solving these simultaneously. So, we need to use substitution. So we know that y is minus 2x and 11. So we're going to put that in there. So, we are going to get x add 1 squared add minus 2x add 11 minus 3 all squared is equal to 20. So x add 1 squared add minus 2x add 8 squared is equal to 20. Okay, now expand the brackets. So x add 1 squared is x squared add 2x add 1 minus 2x add 8 squared is going to give us 4x squared. It's going to give us minus 16x twice. So that's going to give us minus 32x. And then add 64. That is equal to 20. Simplify the left. So we got x squared and 4x squared is 5x squared. We got minus 2x minus 30, positive 2x minus 32x. So that's going to give us minus 30x. And then we got 1 add 64, which is 65. And that is equal to 20. Now this is quadratic, so we need everything on the same side, 0 on the other. So subtract 20. So we get 5x squared minus 30x. Add 45 is 20. There's now happily a common factor of 5, so divide that away. X squared minus 6x add 9 is equal to 0. Factorize that, we get x minus 3 times x minus 3 is equal to 0. It's a repeated root, so we got x minus 3 squared is equal to 0. So that tells us then x is 3. Now we could probably stop there and say, right, we've only got one x value, there's only one solution, so L is a tangent. I'm going to also find the y coordinate. It's good practice. So we know that y is minus 2x and 11. So y then is minus 2 times 3 add 11, which is minus 6 add 11 is 5. So the only point of intersection of L and C is at 3, 5, so L is tangent to C. Boom.